In modern astronomy, we now understand that the cosmos is filled with a vast array of objects beyond the stars. The invention of the telescope over 400 years ago expanded our view of the universe and revealed that even more complexities exist beyond what we can see with our eyes alone. Since its invention, scientists have used telescopes to methodically search and catalog not only the stars, but the ever-increasing number of different objects. As telescopes improved and their ability to gather light became better, an array of faint, extended objects became visible, such as distant comets in our own solar system, clouds of gases surrounding single stars, bright nebulas hosting clusters of stars, and curious, faint nebulas of a different form. Now, this last class of faint nebulas became intriguing to understand whether they were simply small, faint, nearby nebulas or whether they could be very large, distant nebulas. As these faint nebulas were observed and more of them looked at, it became apparent that many had different structures, and there were differing types of them. Of special interest were the so-called spiral nebulas, which displayed a varying degree of overall spiral pattern within their cloudy structures. One of the largest, most studied spiral nebulas was called the Great Andromeda Nebula. By the early 1920s, astronomers now had evidence that these spiral nebulas were actually very distant collections of stars and gas and dust gravitationally bound together. The composition and structuring of these very distant objects were similar to what was here in our own Milky Way galaxy. From this discovery, the size of the known universe exponentially increased. If the stars and nebulas within our own galaxy are separated by great distances, and we can now look out into space and see not only one, but a multitude of other galaxies, then our cosmos truly is vast. With this new class of object now identified, the thrill of exploring God's creation exploded. The race was on to find more galaxies and to probe deeper into the diversity of their structures. After decades of study, what we know about galaxies and their structure is stunning. Estimates for the number of galaxies in our cosmos are ever increasing as larger and larger telescopes are constructed and deeper surveys are conducted. To think that within the span of 100 years, we went from knowing about one galaxy, our own, to now estimating the existence of hundreds of billions, maybe even trillions of other galaxies. Yet, even with the incredible number and the vast diversity, we are still able to see the order and functional complexity that exists within the laws and the matter of our cosmos. Now, several classification frameworks exist for comparing and contrasting galaxies, but by far the most well-known and first developed was by Edwin Hubble. His very basic classification framework included two main sequences: elliptical galaxies and spiral galaxies. Galaxies which didn't fit into either of these two major types were simply termed irregular galaxies. The Hubble system uses the visual structuring of galaxies to determine their classification. Elliptical galaxies are overall rather featureless, and they form a sequence of shapes from a spherically symmetric, like a basketball, to an elongated ellipsoid, like an American football. There are 8 major subdivisions labeled E0 to E7 that account for the variation between these extremes. Spiral galaxies, on the other hand, have lots of visible structuring. 2 major subclassifications of spirals exist. They're called normal spirals and barred spirals, where a barred spiral has a large bar-like structure stretching across its nucleus. Barred and non-barred galaxies are then subdivided in the same fashion, depending on how tightly wound the spiral arms are and how big the nucleus is. Based on the Hubble classification system, if a galaxy has tightly wound spiral arms and a large nucleus, It's given a subdivision labeled by the letters capital S, lowercase a. As the spiral arms are less tight and the nucleus is smaller, the designations progress alphabetically from SB, SC, and SD. From just this simple means of classifying galaxies, we can begin to appreciate how the laws of our universe provide for the existence of a diversity of galaxies. Beyond the stars we see in our sky is a cosmos defined by its design and purpose. As participants within the universe, our role is not as natural creators, but rather observers, seeing the cosmic design that surrounds and supports our lives.